Everyone's going to have you believe that fasting is going to slow down your metabolism and it's going to negatively affect your thyroid function. Well, I'm here to do this video to explain the science, explain the peer-reviewed studies, and explain the scholarly articles that prove otherwise. You see, fasting doesn't necessarily affect our thyroid. Well, it does while we are fasting, but it doesn't affect our thyroid function overall. So before I go into detail about the fasting process, I have to help you understand what exactly a thyroid is. You see, thyroid is a gland that takes in iodine from our diet and combines it with tyrosine to actually create thyroid hormones. Thyroid cells are the only cells that have the capability of doing this. So without the thyroid, we cannot create these thyroid hormones that ultimately regulate our heart rate, our body temperature, and other components of our metabolism. So yes, the thyroid is important, but fasting does not negatively affect it. You see, we have a couple of different components when we look at the overall thyroid system and how we create thyroid hormone. We have T3. T3 is the active form of thyroid. That is the thyroid hormone that is actually causing the activity in your body, increasing the heart rate, increasing your core body temperature, revving up your metabolism, all that. Then we have T4. T4 is a prohormone. It's a prohormone because it encourages the production of T3. Then we have thyroid stimulating hormone. Thyroid stimulating hormone is another precursor to even T4. TSH, when it's high, means that our body is having a hard time producing enough T3, so it's stimulating more production of TSH to actually create more thyroid. But now let's get into the fasting part, because this is going to help things make a lot more sense. And here's the cool thing. Most of these studies are done on longer term fasts, like 7 to 10 days, and they were still showing no negative effect on the thyroid. So when we break it down to intermittent fasting, where we're fasting for short periods of time, the results are even better. So there are two studies that I actually want to reference here. There's a 2014 study in the European Journal of Endocrinology and a 2008 study in the journal Thyroid, and they both concluded the same thing. What they found in these studies is that during a fasting period, after 10 days of fasting, there was a slight decrease in T3 during the fasting period, but there was no change in T4 and no change in TSH, no change in thyroid stimulating hormone. So what this ultimately meant was that a multi-day fast affected the active form of thyroid while they were fasting, but it didn't actually mess up the process of creating thyroid long term. So you're not permanently slowing down your metabolism. What you are doing is temporarily reducing your thyroid that is active in the body, but only during the period in which you are fasting. Once you break your fast, your metabolism revs back up so much that it actually compensates for the slow thyroid production during your fast. So net, you end up ahead of where you were before your fasting. That's why it's pretty powerful to actually look at the science when we're really talking about fasting. The other thing that we have to look at is that it did affect the hypothalamic pituitary thyroid axis. So people that say that it affects that axis are not incorrect, but it does not affect it in the way that your body cannot produce it anymore. It's only affecting the temporary production. It's no different than temporarily slowing down testosterone production, only to have it come back as soon as you're done fasting. All these things don't really matter as long as our bodies overall are in homeostasis. So to help make some sense out of all of this and bring it into a practical application with intermittent fasting, not just long-term fasting, there was a study that was published in the Journal of Medical Sciences that was done on 42 Jordanian subjects that were going through Ramadan. Now, in case you didn't know, Ramadan ends up ultimately resulting in an intermittent fasting style structure. They're usually fasting for 12-ish or 16 hours during the day and only eating and drinking water at night. So, therefore, we can get a pretty solid take of what 30-ish days would look like on intermittent fasting. Well, they tested some blood markers, and what they ultimately found was that although there were some changes in LDL cholesterol, HDL cholesterol, fasting blood glucose, and a couple other general markers, there were no changes in thyroid hormone at all. Barely any change in T3, again, during the time that they were fasting, but no change in T4, no change in thyroid stimulating hormone. So this is the most practical example of an intermittent fasting lifestyle that's been published in a scholarly article or a peer-reviewed study. Pretty amazing stuff. So I do understand where a lot of this comes from though. People tend to think that whenever we don't eat, our metabolism slows down. And eventually, if our caloric intake is too low, our metabolism can start to slow down. But that's only if you are reducing your caloric intake for a long period of time. The example being this. you start intermittent fasting, and after the fast, you only manage to consume 1,000 calories. And then you fast every day. So ultimately, you're only consuming 1,000 calories every day. Well, eventually, your metabolism is going to adjust to that. It's not about what you're not eating. It's about how much you actually are eating. So if you are fasting, it's important to make sure that your caloric intake is still high enough that you're not lowering your basal metabolic rate. That's why I'm such a fan of introducing fasting only 3 or 4 days per week, especially when you're starting out. So especially for those that are concerned about slowing down their metabolism, you are much more apt to increase your metabolism by going through a fasting protocol. As always, keep it locked.